Hello, and welcome to this webinar. My name is Ian Fletcher. I am the Senior Product Manager for Temperature-Resistant Coatings, and I shall be giving this presentation, which we have called Combating CUI the Universally Simple Way. So what is CUI? Corrosion under insulation, or CUI, is the silent killer that you can't see, and if left unchecked, will lead to a serious problem. CUI occurs due to water ingress through an insulation system, creating a highly corrosive environment against the underlying steelwork. And CUI's corrosion rate can be up to 20 times faster than atmospheric corrosion, resulting in steel loss of between 0.5 and 3 millimeters per year. Corrosion of the substrate is difficult to identify without the removal of the insulation and can therefore go unrecognized for significant periods of time. As a consequence, there is considerable degradation of steel piping and vessels with the potential for catastrophic failure, and this then leads to premature repair or replacement. CUI typically occurs between -4 degrees Celsius and 175 degrees Celsius, and is at its most severe at around 60 degrees Celsius. It is fair to say that very little equipment experiences a constant temperature. It may undergo cyclic temperature processes and will be at ambient during pre-startup and shipping to site, during annual shutdowns and maintenance, and during unplanned shutdowns and outages. So it is fair to say that all piping and equipment under insulation will enter the CUI temperature range at some point in its life. As refineries and petrochemical plants have large areas of insulated piping, it comes as no surprise that there are many challenges during new construction projects. Oil and gas new construction projects can involve thousands of process pipe spools, valves, and other associated equipment. Traditionally, different coating schemes have been used depending on substrate type, insulated or uninsulated requirements, or service temperature range. And because of these very varied needs over the years, the oil and gas industry has developed complex specifications utilizing specialist coatings technologies. With so many different specifications, a variety of different generic types of coatings can be required, which have to be carefully selected depending on what temperature range or insulated or uninsulated application is needed. And if you add different colors and pack sizes, a typical pipe spool coater's storeroom can start to get very complicated. A pipe spool blaster and painter needs to know how many different coatings are required, which spools need insulation and which ones do not, which ones are for cyclic service and which ones are not, and then how many different coating systems are needed. This segregation into each coating category is critical in order to avoid making mistakes and using the wrong coating system on the wrong pipe spool. This complexity can add costs for blasters and painters, resulting from the increased risk of application errors, reduced productivity, and increased paint waste and disposal costs. And of course, mistakes can be made. Bulk supplied items can arrive at the fabrication site with the incorrect coating for the final operating environment, requiring expensive on-site rework. Up to 20% of bulk supplied items can be installed with an incorrect coating system for the final operating environment, again resulting in further rework, which can cause delays and increased costs. To overcome this complexity, we developed universal pipe coatings as a universally simple, reliable, and efficient solution for both specifiers and applicators. The universal pipe coating range, also known as UPC, is comprised of two products: Interbond 1202 UPC for process piping and equipment operating between -196 degrees Celsius and 650 degrees Celsius, and Interbond 2340 UPC for process piping and equipment operating between -196 degrees Celsius and 230 degrees Celsius. Both are suitable for insulated and atmospheric service, can be used on stainless steel and carbon steel, and are compatible with a wide range of top coats. Both products deliver a simple solution as they have a wide range of application characteristics. That means that they can replace all of the traditional coating specifications to just two. Interbond 1202 UPC can reduce 5 coating schemes to 1, and Interbond 2340 UPC can reduce 3 coating schemes to 1. As the vast majority of process piping operates below 230 degrees Celsius and CUI occurs below this temperature, I am now going to focus the rest of this webinar on Interbond 2340 UPC. Interbond 2340 UPC is an alkylated amine epoxy technology, which is a next generation epoxy phenolic, delivering corrosion and temperature resistance from -196 degrees Celsius to 230 degrees Celsius. Interbond 2340 UPC provides enhanced corrosion protection and has been shown to comply with the performance criteria of the ISO 12944 Part 9 2018 standard, meaning it is suitable to be used in CX offshore environments. It has been shown that other epoxy phenolics do not perform well in this test, suggesting that they do not provide adequate corrosion protection in aggressive environments. Interbond 2340 UPC has been tested in the vertical pipe test, as described in the ISO 19277 standard, used to pre-qualify coatings for use under insulation. In this test, it was shown that 2340 UPC performed just as well, if not better, than traditional epoxy phenolics, with no coating defects observed up to 230 degrees Celsius. 2340 UPC also has enhanced erosion resistance. Typically, epoxy phenolic schemes are specified without a durable top coat. As a result, when used in uninsulated service, there have been examples seen in the field where the epoxy phenolic coating has been eroded, reducing the dry film thickness and leading to poor corrosion protection. In accelerated erosion testing, Interbond 2340 UPC has been shown to far outperform traditional epoxy phenolics, losing considerably less coating thickness over the same time period. Another feature of typical epoxy phenolic coatings is poor crack resistance. Epoxy phenolics show poor tolerance to over-application, and it is common to see cracked epoxy phenolic coatings and corrosion occurring during operation. We carried out a detailed study of over-application tolerance. First, we looked at traditional epoxy phenolics. The results were categorized in 3 ways. Green was for panels that showed no sign of any cracking. Orange, there was some cracking around a weld, and red, there was cracking across the face of the panel. What we found was that for some temperatures and film thicknesses, a traditional epoxy phenolic performed well, but as the film thickness and temperature increased, cracks started to form. The overall conclusion was that to get the temperature performance expected, a very narrow dry film thickness range of 2 times 100 microns was necessary, and even then it cracked at 200 degrees Celsius. When we compared Interbond 2340 UPC's performance in the same test, we found that it performed very well across a wide range of coating thicknesses and temperatures. Interbond 2340 UPC, being a next generation epoxy phenolic, has greater film flexibility compared to traditional epoxy phenolics, and this allows it to withstand over-application so much better. The challenges of coating complicated process pipe shapes and sizes should not be underestimated. An epoxy phenolic specification of 2 times 100 microns was used to paint pipe supports for a large modular construction oil and gas project in China. Application by both spray and brush led to many areas being over-applied, and so the applicators had to abrade all of these areas to reduce the dry film thickness and bring them into the required specification tolerance. The coating job that was supposed to take just a few days ended up taking 2 months to complete. As Interbond 2340 UPC provides increased thickness tolerance, the risk of premature failure, even if DFTs exceed specified thicknesses, is greatly reduced. Epoxy phenolics typically cure very slowly at temperatures below 10 degrees Celsius, and this can add heating costs to the application process, such as the use of heat lamps. Conversely, 2340 UPC can be used down to -5 degrees Celsius, being hard dry in 10 hours at this temperature. 2340 UPC has faster hard dry times and has much shorter overcoating times, than traditional epoxy phenolics. This means that compared to traditional epoxy phenolics, Interbond 2340 UPC allows process piping and equipment to be coated up to 85% faster, which greatly improves pipe shop productivity. The slow curing of traditional epoxy phenolics can have unexpected consequences. The pipe spool coating project that was being carried out in the winter required the paint shop to be heated to 15 degrees Celsius. An epoxy phenolic was applied during the day, but then the paint shop heating system was turned off overnight. This caused the shop temperature to drop and the epoxy phenolic coating to remain wet the next day. The painting schedule was then delayed by 48 hours whilst the pipes were moved to another heated room. After forced curing, the coating surface required extra washing and then abrasion to clear coating contamination after moving the pipe spools. Overall, an extra week was added to the coating schedule, as well as increased labour and heating costs. Had Interbond 2340 been used, none of this would have happened, and the shop could have maintained its productivity. So to summarise, Interbond 2340 UPC, a next-generation epoxy phenolic, has been formulated to provide very good corrosion resistance at both ambient temperatures and in the CUI zone, provide excellent crack resistance if over-applied, provide low temperature cure down to -5 degrees Celsius, and have enhanced erosion resistance. Interbond 2340 UPC greatly simplifies specifications, which means faster shop throughput and less waste for fabricators and applicators, less rework costs and project delays for fabricators and EPCs, and greatly reduce CUI risks for owners and operators. 2340 UPC together with 1202 UPC make an ideal CUI solution for new construction projects, as they can greatly reduce specification complexity and all the costs that this brings. So there we have it, universal pipe coatings, the universally simple, reliable and efficient solution to overcoming coating complexity and reducing CUI. Thank you for listening to this webinar.